Hello all, in this session we are going to discuss schema refinement, problems caused by redundancy, decompositions. Also the problems related to decompositions. Firstly, what is schema refinement? Normalization or schema refinement is a technique of organizing the data in the database. It is a systematic approach of decomposing the tables to eliminate the data redundancy and undesirable characteristics like insertion, update, and delete anomalies, which means that schema refinement is a process of organizing the data properly in the database. If the data is not organized properly, then what happens? It leads to several inconsistencies. So these inconsistencies can occur due to the problem of redundancy. What do you mean by redundancy? Redundancy is nothing but duplication of data. If same copy of data is available in the database in different locations, then it leads to what? Several inconsistency problems. So thereby it is necessary to follow a systematic approach in organizing the data in the database. And that approach can be made through decomposition. Problems caused by redundancy. Storing the same information redundantly can lead to several problems. Redundancy, as said before, it is nothing but the same copy of data is present in different locations, said to be redundancy. Now we have an example table here with several set of attributes like SID, SNAME, course ID, and course name. Also, there are several values which are listed under each and every attribute. Now let us see the different problems that we face with the redundancy. Firstly, we have update anomaly. Anomaly is nothing but it is a problem. Anomaly means problem. Now, what is the problem that you are facing when you are updating the data in the table? So that is, if one copy of such repeated data is updated, an inconsistency is created unless all copies are similarly updated. Now here in the example, when Java is updated in this particular place, wherever a tuple containing the course name as C are also be updated to Java. If not, what happens? It leads to several inconsistencies. So in our table, we have only 4 tuples. So likewise, as we know that the database is a collection of huge amount of data and the data is stored in a form of tables. So the table may contain thousands and thousands of rows. So in that case, what happens? If in one particular place, the value is updated, similarly, in all the places under thousands of rows, the value is to be updated. So if the value is not updated, then what happens? It leads to an anomaly called update anomaly. And this again, in turn, leads to a problem called inconsistency problem. So that is what is update anomaly. Now let us see what is insertion anomaly. It may not be possible to store certain information unless some other unrelated information is stored as well. So what kind of problems that you are facing when you are trying to insert a record into the table? So that is, suppose that I would like to introduce a new course, say Python, to our students. Now what will be the course ID for it? Let it be C03. Now, if I would like to insert these values into the table, along with these values, I may also have to insert some other unrelated information. Unless and until this unrelated information for SNAME and SID is inserted, I may not be able to insert this course ID and course name Python. So this is the problem which we are facing with the insertion of records into the table. And next, coming to deletion anomaly. It may not be possible to delete certain information without losing some other unrelated information as well. What do you mean by this? For example, would like to delete this course name, say C++, from the given table. Now, when this course name is removed, this course ID value is no longer required. So thereby CO1 is also to be removed from the table. So when this sort of information is to be deleted from the table, it is only possible when the unrelated information is also be deleted. So that is what is given here. It may not be possible to delete certain information. That is, this CO1 and C++ may not be deleted without losing some other unrelated information as well, without losing SID1 and SName Rajesh as well. So if these values are also deleted, then only we are able to delete the course ID and course name from the table. So this is the problem we are facing with the deletion anomaly. Now let us learn what is decomposition. The process of breaking down a relation into several smaller relations is known as this decomposition. Firstly, why do you have to decompose a table? You are breaking down a larger relation into several other smaller relations. Say R is a relation which is broken down into R1 and R2. So this process of breaking down a relation into several multiple smaller relations is known as what? Decomposition. So as we have discussed the problems of redundancy, in order to avoid such kind of anomalies that caused due to redundancy, we are moving with the concept of decomposition. Decomposition is mainly used to normalize the table or organize the data in a proper format. And remember, when the decomposition is done, try to ensure that the information or the data is not lost. Problems related to decomposition. Here are the several problems which are listed over here. Firstly, we have loss of information, and next loss of functional dependency, increased complexity, redundancy, and performance overhead. Let me take an example to make you understand what is loss of information is. I'm going to consider a relation, say R, with several set of attributes A, B, and C. And there is also a functional dependency which exists between A and B. Now, if R is broken down into several other relations, say R1 and R2, consider that R1 holds attributes A, B, and R2 is having attributes like B and C. Now, if the original relation can be perfectly reconstructed using a natural join that you can make between R1 as well as R2, this symbol is known as join operation. So when a natural join is performed between R1 and R2, and if you are able to reconstruct the original relation, that is R with the attributes A, B, and C, then it is termed as a lossless decomposition. If not, it is termed as a lossy decomposition. Now let us understand what is loss of functional dependency with an example. Consider that there is a relation R with attributes A, B, and C. And also it contains the following functional dependencies, that is A tends to B and B tends to C. These are the functional dependencies that are derived for this particular relation. Now the thing is, suppose that if the R is broken down into two relations, say R1 and R2, with the attributes for R1 namely A and B, and for R2 we have B and C. Assume that the functional dependency for R1, B, A tends to B. It is because R1 contains what? A and B attributes. So from among the functional dependencies that are already defined for the original relation, you can say that A tends to B is a functional dependency which can be given for this relation R1 as it contains attributes A and B. Similarly, we have another relation that is R2, and R2 with the attributes B and C. So thereby it can contain the functional dependency B tends to C. Now what happens? In this case, when the decomposition is performed, it is preserving the dependency. That is, dependency preserving happens because all the functional dependencies of original relation R can be found. Suppose the case that if our original relation also contains another functional dependency, that is A to C. Now, when it is broken down into R1 and R2, we find that there is only two functional dependencies that are not lost. Then what about A tends to C? R1 and R2 may not preserve the functional dependency of the original relation. And next, coming to increased complexity. To increase the number of tables. Thereby, it can complicate queries and also it becomes difficult in maintaining the task. So that is about the increased complexity. Coming to the redundancy. If the decomposition is not done properly, then what happens? It may not eliminate the duplication of data. So if duplication of data is not eliminated, then we may be facing with the problems of inconsistency. Coming to performance overhead. An increased number of tables may lead to what? Complex SQL queries. Right. Now what happens if complex SQL queries are increased? It may lead to performance overhead. Performance overhead will also increase. So while decomposing, here we know that the decomposition is a powerful tool in order to achieve the database normalization, or in order to organize data in a database properly, we are going with the concept of decomposition. So when this is done, we know that it in turn reduces the anomalies that we are facing with the problems of redundancy. So thereby, it must be done thoughtfully in order to avoid introducing new problems. This is all about the problems which we may face during the decomposition of a relation into several other smaller relations. Hope you have understood today's lecture. Thank you.